Yo, what's up? Diddy's back. Today I'm gonna be just reviewing what I messed up last time. So perfect hashing. I think this image perfectly explains it. But what it is instead, it's a smart way of managing hash collisions. So instead of before with I think linked hashed tables where if there was a colliding key with the hash function, it would create a linked list where it's inserting it at the front. Instead of this, what we do is if there's a collision with the hash function, what it does is it extrapolates that, it creates another hash table with another hash function with keys in this way. For example, let's assume we have key 1, key 2, and key 3. Assume h of k1 is equal to h of k3. Does that make sense? Knowing this, we can put k1 over here. K2 will probably go somewhere over here. When we try K3 again, we know the value is the same. However, we label this node 0 as seen over here on the left side, similar to what we have over here. By labeling on the left side, we know that these nodes are called these numbers, and by the hash function of h2 of 0, we can take the 0th node, match it with the h2 function and the k3 node that we have to map it in another sort of table. And this kind of works well, especially because it allows us to sort of look at the whole hash table in its entirety without looking at specific parts. It's a clean way of organizing it so there is no hash collisions. Along with the fact that it's O of one time because you only have to search one box, one box. I mean, I guess it could be O of n, but technically because each function of looking at the thing is O of one time, the chances of it like actually having one node and multiple linked lists is very low, which is why I think that it's different. So instead of making a linked list of keys hashing to slot J, using a secondary hash table hj with the hash function hj is what we're doing. In order to guarantee that there are no collisions in the second layer, we will need to let the size mj of the hash table be the square of the number of nj of the keys hashing to slot j. If that makes sense fully, I think people might be homophobic about me low key because I got this whole room, a conference room of like 30, 40 people that can sit in one spot. Did you not hear it coming? Take care of it coming. Don't put that. Although you might think that quadratic dependence on MJ and NJ may seem likely to cause overall storage requirements to be excessive, we shall show that by choosing the first level of hash function well, we can limit the total number of space used to O of n. By doing this, we use the hash functions chosen from the universal class of section 11.33, which is the first level hash function, which comes from the class of h of pn. In the section 11.3, p is a prime number greater than any key value. Those keys hashed into slot j are rehashed into a second. I think I scared them away, which is pretty good. Okay. This is why it works, right? Alright. Apologies. Let's just re-go over this because I think this is a really important section, but we didn't really go in. In order to guarantee there are no collisions, we need to make it so that the size of mj of hash table sj is the square of that value, if that makes sense. Square of the number nj of the keys hashing to j. So let's just go through that real quick. How does that look like? If we have slot j over here, We want no collisions, so we let the size of MJ, whatever MJ, I don't know what MJ is, let the size of MJ be square to the size of NJ in some way. Hashing to slot J are rehashed into a secondary hash table Sj in the size of Mj using the hash function Hj, which is chosen by class HPMJ. I don't know what that really means. Low key, I'm gonna just GPT this later and figure it out and I'll explain it to you. But we can go up and here's some theorems. We can also go through this later. But yeah, go to 81 to 82. And then I think there are problems which we can also go through when you have a little bit more time. I think these are solutions and chapter notes. It's pretty good. And that's how we finish this chapter. I'm gonna start a new video with just going through this stuff, but hopefully that was useful. If not, I am improving. I'm a student just like you guys, bro, but hopefully you can have fun with me. Thanks, guys. Please subscribe. I hope you enjoy me yapping for a bit. All right, peace. I don't know how to make the peace sound, so you know that, right? Peace. All right, bye.